All right. Okay, let's review why those are circles, okay? Circles because there's no plus or minus in them, and the number in front of theta is 1. Now, when they involve plus or minuses like the last 4, they become Lambison family. Like on number 23. Number 23. Both your A and B have the same absolute value. Alright, so it is a special type of Lambison called cardioid. Alright, so a cardioid means there's going to be a dimple at the what? Pole, and that's what you see. Does everybody agree with my chart there? Good with that. Number 24 is another cardioid. Dimple at the pole. And do you notice that this involves cosine, so it's around that horizontal, that is sine around that vertical. Okay, now, here we see that the A value is less than the B value, so it's going to be a Lambison with an inner loop. Okay? You see I made a mistake right there. Is that what y'all's look like? Are you sure? I hope I didn't confuse you there. Right there. Yes.
Isn't -2 greater than -2?
You take the absolute value. Are we good on 25? All right, let's look at 27. 27 is kind of a big one. The absolute value 7 is greater than 2. Absolute value 7 is greater than 2. So it would be a dimple, but it would not be at the pole. So you look at this. The dimple won't be at either one of those points because they are the same little path. This is furthest from the pole, so it won't be here, so your dimple will be at that. Are we good with those? Did y'all have any more to do on those? Or is it just those 4? 27. Okay, 27, your absolute value is greater for the A, so it would be a dimple. Alright. You have to extend this because it's going to be on ring 1, 2, 3, 4, 5, 6. Was it 7 or 8? 8 out there. Do you see that? Are we good on that one? Alright, let's look at with roses today. Okay. The difference between a rose and a circle, guys, is that the number in front of your theta is greater than 1. Okay, that's how you tell between a rose and circle. Going back to circles, there's always a point at the what? Pole. Okay, point at the pole for a circle. Now, alright, your roses are going to have flower petals. That's why they get the word rose. They're not going to look like a rose, they're going to look like a flower, but they call them roses. Alright, now this number right here tells you how many petals. If it's an even number right there, 2. What's 2 times? You always want to multiply by 2. If it's even, what's 2 times 2? This means it's going to have 4 petals. If it's an odd, you don't multiply it. It's whatever's there is the number of petals. So on this one, you have 3. So even you multiply, odd you do not. You okay? Good. Alright, now, this number right here is your A value. That tells you how far your petals are going out to what ring, okay? How far they're going to go out to. Now, you have to set up an equation to figure this out. Now, if it's even, if you're going to have an even number here, you're going to have 2 equations. If it's odd, you're going to have 1 equation, okay? So you want to know what makes this equal to 5, because that's the ring it goes out to. So you set up 2 equations. 5 equals 5 sine 2 theta. And negative 5 equals 5 sine 2 theta. Because you're wanting to know what makes that equal to that 5 or negative 5, because that's how far your petals are going out, okay? I'm showing you the long way. I'm going to show you a shortcut in a minute, okay? So you appreciate it in a minute. Now, you want this to get, you want the sine part to be by itself, so I'm going to divide this by 5. So I have 1 equals sine 2 theta. Divide this by 5. So guys, you always set this equal to that number A value. Like here, I would set that equal to 5. Down here, I would set that equal to 2. So every time, you're going to have to divide by that number to get rid of it. So what's it always going to equal here? 1 and what? So you don't have to show that step. If you just set them equal to 1 and -1 each time, and don't put that 5 or whatever's there in front, you don't have to worry about doing that step, okay? Now, you said, Mr. Tesher, okay, you said odd is only one equation. You only do the positive one for the odd ones, okay? Does that make sense? All right, so now, guys, these are the equations you didn't kind of not like. You remember when we studied the trig equations where you had to do plus 2 pi n, and you had to plug n equals 0, n equals 1, n equals 2, and get all those values? That's what these equations are. That's why we had to study those. All right, so you work backwards. What sign value gives you 1? Pi over what?
4.
Sine of 1. Need you think hard. What sign value? Pi over 2. Does everybody understand that? So you're going to say sine of, wait, don't put that up. I'm going to put 2 theta equals pi over 2, because you just told me plus pi over 2. Since this is sine, do I put pi in or 2 pi in? 2 pi in. Now, how do I get that theta by itself? Divide everything by what? When I divide that pi over 2 by 2, does that affect the numerator or denominator? So that's going to be pi over 4, isn't it? And these 2's cancel out. Now, if I'm going to have 4 petals, 2 of your petals are going to come from this equation, 2 is going to come from this one, okay? So you know you got 2. If I plug 0 in, what would that give me? Pi over what? Pi over what? 4, because isn't that 0 and you're just left with pi over 4? Okay? If I plug 1 in, 1 times pi is 1 pi plus 1/4, that would be what? 5 pi. Okay, so there's 2 of your petals, okay? Now I'm going to go over here. What sign value gives you -1? 3 pi over 2. Very good. So I'm going to come down here. 2 theta equals 3 pi over 2 plus 2 pi n. Divide it by 2. Theta equals 3 pi over 4 plus pi m. I plug 0 in. I plug 0 in. Get 3 pi over 4. I plug 1 pi in. I get 7 pi over 4. So there's my 4 petals right there. You put a dot at the pole. You're going to graph each of the petal at each of them. Now you say, what ring do I go out to? I go out to that 5th one right there. So I have pi over 4, so I'm going to go out to pi over 4, 1, 2, 3, 4, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this is how you draw them. And that's your graph. Okay, let's look at number 10. There's going to be 3 petals here. Do I have to go through this long process, or can I just say sine of 3 theta equals what? 1. Do you see that? Because it's odd, I only have to set it equal to 1. What sign value gives you 1? Which one? Pi over 2, doesn't it? Now I'm going to divide everything by 3. Theta equals pi over 6 plus 2 pi over 3. if I plug 1 in, that would give me just what? Pi over 6, won't it? I mean, if I plug 0 in, I will get pi over 6. So one of my petals is going to be at pi over 6. Remember, I only have one equation here. I got how many petals? So I'm going to have how many answers right here? 3. I plug 1 in. That gives me 2 pi over 3 plus pi over 6, which will give me 5 pi over 6. I plug in 2. That gives me 4 pi over 3 plus pi over 6, which is 9 pi over 6, which will be 3 pi over 2. You can use your calculator. Go to the origin. We're going out to what ring? This A says I'm going to draw that out to what ring? 5. So pi over 6 here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's my flower. Now, number 11, Zach, how many petals do I have there, buddy? It's the one in front of theta. It's odd, so do I need to multiply that? No, you're going to have 3 petals. And they're going to go out to what ring? 2. Alright, so I'm going to set just this part. Cosine of 3 theta equals, do I set it equal to 1 or negative 1 since it's odd? 1. Alright. Cosine of 3 theta equals 1. What value of, on the unit circle, gives you a cosine of 1? 0. So I'm going to have 3 theta equals 0 plus 2 pi n. Divide everything by 3. Theta equals 0 plus 2 pi over 3 n. I plug 0 in. That's going to give me 0 because that goes away, left with 0. I plug 1 in. That's going to give me 2 pi over 3. I plug 2 in. That gives me 4 pi over 3. So I have 1, 2, 3 petals. That's what I wanted. So now I'm going to graph this. I'm going to go out to the second ring. And that's my flower. We'll pick up on number 12 tomorrow, but your homework is 28, 29, 30, 31, 30. How about you just do 28 through 31? How about that? 28 through 31. Just do 4 problems. Homework's 20, yes.
38 or 31, and then the angle of pi over 8.
Okay, which one?
31.
I remember that. Okay, omit 31, do 28 through 32. Yeah. 28, 29, 30, 30. You need 4 problems first. Okay? Thank you. I remember once, but we're not going to deal with pi over 8. Thank you. Was the quiz okay? Yes. I'll be in a better mood tomorrow, I promise.
Yeah, but they're probably more expensive. So it's probably just like the same. I don't know. I like this stuff. Huh? No.
How y'all feeling the roses? I need a hand sit on. How do you feel in the roses?
I'm good.